Well, this is very straightforward, so I've written out the most straightforward parts, right? In other words, this, obviously just filling in the del operator where it goes, and then applying the del operator to F, and then the distributive law for the cross product, right? So now, we have an I cross I, which is going to give us 0, right? So it doesn't matter, it's a partial of FF. Well, okay, I'm going to write it out anyway. It's FXX times I cross I plus FYX times I cross J plus FXY times J cross I plus FYY times J cross J, which equals what? Well, this is 0 and this is 0, right? So that's 0, that's 0, and we end up with FYXK plus FXY times negative K, which is FYX minus FXY times K, which is 0 times K, or the 0 vector, right? It's very easy. Now, if you have to do it for 3 dimensions, and cross product is only defined in 3 dimensions, okay? And it doesn't look like it's defined in 3 dimensions because we're just doing it in 2. Okay, well, if your functions are just functions of 2 variables, then you can confine it to 2 dimensions because your 3rd dimension kind of goes away. But it arises again when you get the cross product as a multiple of your K vector, right? Okay? Showing you, among other things, that, well, I mean, that's because the cross product is perpendicular to the 2 vectors, but these really aren't vectors.
Is this calculating the curl?
Huh?
Is this calculating the curl?
Well, we calculated now the curl of what?
A conservative vector field?
Very good. Okay? I expect you to say a curl of the gradient of F, but gradient of F is a conservative field, right? So, the curl of any conservative field, because any conservative field is a gradient of some scalar function, right? Called the scalar potential. Think gravitational potential, gravitational force, okay? Gravitational potential measures potential energy per unit of mass. Anyhow. Okay? Is this a test for conservative field? Well, we've shown, this is a logical statement you need to ponder a little bit, okay? We've shown that if the field is conservative, then this is 0, right? The converse doesn't necessarily apply. You have to prove it. If the curl is 0, does that mean you have a conservative field? Okay? So you want to think about that a little bit, and your book will tell you things. Okay? So we've proven if conservative, then the curl is 0. We haven't proven if the curl is 0, then curl is 0. Then the field's conservative, okay? So we haven't proven the converse of the result that we just proved.
It's not true, is it?
Well, think about it. Okay? Why would it not be true? Is there something you can add to this function, to this gradient here, okay, that would make the curl not zero but wouldn't affect the f function? So you can ponder that. I'm glad you're thinking about it. We're not going to address it right now.